Good morning, everybody. My name is Muhammad Zainul Lubis. I want to present our research in the third international conference on applied engineering, Polytechnic Batam, Indonesia, with the title Physical Oceanography and Hydrodynamic Modeling in Tembesi Reservoir Waters, Batam. With the first author is me, Muhammad Zainul Lubis, and the next author Bordiana Octaviano Kustin, Widya Rika Pustiza, Amanda Wahyu, Astuti, Satria Antoni, Isnania Rahima, Husnul Hausarian, and the last author is Budi Agung Prasetya. How about the interaction with our research? Batam Island is rapidly developing as an industrial area. Several studies have been carried out related to the physical condition in bottom water to see the relationship between temperature and the chlorophyll. Besides that, there is a lot of research that needs to be done in the coastal and seawater to analyze the environmental problems caused by human and natural activity. This problem is occurring not just over and bridge, but on land and cause the formation of reservoirs by natural process with a range of time around 2040 until 2090. Starting from 2040 to 2090, the water level of this reservoir is increasing. The study to analyze the water level can be performed by hydrodynamic studies or remote sensing. Hydrodynamic study can be done through measuring data directly in the areas that undergo the RUB, while remote sensing can observe and analyze without the direct contact. How about the research method or the research? The study was conducted on October 60 until 80 in 2090 in Tembesi Reservoir. Primary data such as water level were acquired by water level measurement GOGI, SUTT tower location by GPS, and bathymetry by Garmin GPS map 585. While the secondary data include wind data was obtained from European Center for Medium Range Weather Forecast, it's ECMWF. We can look at the recent location. Yes, is Tembesi Reservoir in Batam Island, Indonesia. And recent method, the basic equation of hydrodynamics. Water is an impressible fluid, which means that its density rho is constant. The water density can change by pressure and temperature. In the above equation, T is time x, and z are the coordinate axes. They have longitudinal transfer and vertical direction. These are U, V, and W are the velocity that exists for a momentary direction of x, y, and z. Rho is a pressure. This is you can see for the formula. The equation above the continuous equation, this is equation 1, equation 2, 3, and 4 are known as the Navier-Stokes equation. And research, and our research, we have result and discussion about the water level is very influential in generating currents and also determines the extent of exposed tidal flats, especially in shallow water areas. The daily average of water level has been collected from the water level measurement for 3 days from 9 am to 7 pm. The average of water level obtained on the first day is 0.36 meter, and the second day with 0.307 meter, and the third day is 0.3029 meters. And we can look at the figure. It have three figure. This is a value of water level. It's a first day, second day, and the third day. Uh, the three figure have not be same with the water level. Yeah, and then the result and discussion for our research about hydrodynamic model. We conduct depth mapping was used German GPS map 5 585 was equipped with the ability to detect the bathymetry on each point in the Tembesi Reservoir, especially in the bright Batam Tower area. The range of water depth is means 1.05 until mean 5.90 meters. Yes. The information of the water depth is important to make the hydrodynamic model that will be carried out in the existing condition of the Tembesi Reservoir. This is a map of Tembesi Reservoir depth. You can look at that, have a bathymetry value and scale bar. This is a point with the red color. This is a tower point, yeah, location of tower, associated tower, yeah. And result discussion about windrows and hydrodynamic model. Two dimension based on the windrows. The wind is dominant towards to the northern region with value 51.60% and wind speed ranging from 1 until 4 knots. The percentage of wind speed below 1 knot is 3.23% and the independent variable in the percentage of wind data processing is 1.61% with the lowest wind speed in the range of the 0.1 until 1 knots. Also shows the frequency distribution table of the speed and wind direction. Windrows, this is a figure of windrows around Tembesi Reservoir waters bottom. Which is a dominant direction is a north to north direction, yeah, with the high cast is above 2.4 knots. And the next result on discussion in general, the 2D hydrodynamic simulation model is able to represent the hydrodynamic condition in the coastal area to see the process and time occurrence of the tidal flood. The elevation modeling of the water surface and water current was done during the water filling process by the river, rainfall, etc. before the water discharge from the outlet, and the second when the water in the reservoir has been discharged from the outlet in the sea. The hydrodynamic model will be simulated for 80 days with the assumption that the extreme condition of the water level and current flow rates will be obtained on the western season this October. Yeah, you can look at that to figure A and B. Yeah, this is a modeling the beginning, water surface elevation and current flow during water filling process before the water discharge from the outlet. And the next result on discussion, yeah, we can look at that. It's a figure model of the final. Yeah, this is water surface elevation. With the case, the water discharge from the outlet. Yep. All the feature have not be same. It's a direction and elevation value, and the next feature is a position right of V, modeling of the beginning water surface elevation, current flow in the water in the reservoir has been discharged from into the sea. Yeah, the last of the slide result of discussion. This feature, the current flow when the water in the reservoir has been discharged from the outlet into the sea. Yep. The result of 2D hydrodynamics model clearly seen the water elevation modeling, which progress during filling process before the water is discharged from the outlet is 0.023 meters. This result is equivalent with the relative of small current flow rate ranging from the 0.0020 Yep, we have a conclusion. Is a three conclusion. The first is the result of final water elevation during filling process, great water elevation with high headcount rate. And the second water elevation to the current flow at the final condition when to the water in the reservoir has been discharged from the outlet into the sea has a high gas value compared with the other condition. And the last conclusion, this can be stated that the water level is important value to making the model. The entire S2T tower location was all submerged and flooded, especially the tower which located in the southern of the Tembesi Reservoir, Batam. Okay, thank you very much for attention and good morning everybody.